Here's a problem where we are to evaluate several logarithmic expressions without a calculator, and if we ever hit one that there's no answer, we will write D&E for does not exist. So before I even tackle how to do this, what's really necessary for you to be able to do these problems is to have some familiarity with exponent rules. So down here sort of as a cheat sheet, I want to talk about what it means to take 5 to the negative 2. What would that be? Say 5 to the negative 1, and say 5 to the 0, 5 to the first power, and 5 to the second power. What I'm hoping down here will be like a little cheat sheet for me to use to help me with these problems. So 5 to the first power means it's just 5, and 5 squared means 5 times 5, which is 25. So first off, just to note that when you take a number and raise to the 0 power, the definition is that that's a 1. The definition of a negative exponent is as follows. 5 to the negative 1 really means 5 to the first. It just means that the 5 to the first should be in the denominator. And 5 to the negative 2 would be explained in a very similar way, except that, the negative exponent would mean that I move it to the denominator, 5 to the second power. And 5 to the second power is nothing more than 25. So 5 to the negative 1 came out to be 1/5. And 5 to the negative 2 came out to be 1/25. I'm going to need all of these facts to do these problems, and that's why I'm doing it. And you might notice that every time my exponent goes up by 1, that the answer gets multiplied by 5, and that's exactly what it means to have a base of 5. What I didn't talk about is fractional exponents, so it turns out we need to talk about that real quick. So if ever you had, say, the square root of a number, it turns out that if you have the square root of something, you can write the answer without the square root, and this works for all radicals, in fact. If it's the mth power, and your index is n, so if it's square root, your index is a 2, but I'm just going to show you the general property because I can. Whatever the index is there, so if it was square root, it would be a 2, cube root would be a 3, etc. You can write this without a radical by using the exponent property that just says that this is nothing more than x raised to the m divided by nth power. So whatever the exponent was, you divide by the index, and that becomes your new exponent now. So, for example, I am going to have to look at the square root of 5 in this problem. And the square root of 5, you can think of it as, since the exponent's not written here, as the exponent's a 1. And if it's the square root, we don't write the index. So the fact that there's no index there means that the index is a 2. So now that I know that that's a 2, I can write this as 5 is my base. If you want x is 5. My m is 1, and my n is 2. So it turns out taking the square root of 5 is the same thing as taking 5 and raising to the 1/2 power. If you have these facts, then evaluating these without a calculator is nothing more than writing out the meaning of the notation. So for example, log base 5 of 1 really means, whatever that number is, question mark, really means that 5 is the base, and you're supposed to take 5 and raise to some number to get 1. So to convert this from what's called log form to what's called exponential form, I would take 5, raise it to the question mark, and that would be equal to 1. So you would have to know 5 to what power is 1? Well, I have that down here. That's this little fact here that I went through. It turns out that if you want to take 5 and raise to a power to get 1, there's no other way to do that than to raise to the 0 power. Now, having said that, where there was a question mark here, I know the answer. 5 must get raised to the 0 power to give 1. So log base 5 of 1 is nothing more than the number 0, and maybe just to summarize that, I'll write equals 0 here. The next problem, log base 5 of 5, I like to write equals question mark because this is equal to some number. That's our job, to find that number without using a calculator. And then if you converted this from log form to what's called exponential form, you would argue that 5 needs to get raised to some unknown power. That's our job, find that power. And if you take 5 and raise to that power, you are to get 5 as an answer. And that's a pretty easy one. 5 to the first power is 5, so that's this fact right here. That was equal to 0, this was equal to 1. And you could check it, 5 to the first power is 5. So you can see where this is going. 5 to what power would give me 125? 5 to what power would give me 125. We did 5 squared is 25. We never did 5 cubed. 5 cubed would be 5 times 5 times 5. And if you do that, 5 times 5 is 25. and 25 times 5 turns out to be 125. So the answer to this one is you have to cube it. That you'd have to take 5 and raise to the third power to get 125. So if the answer here is 3, that means the answer here is 3. And you could check this by saying 5 to the third power is 125. So that was 3. Let me skip this one for now. Let me move on to this one because it's in my list. Log base 5 of 1/5 would say that I need to find what power I have to raise 5 to get 1/5. And again, if you like, you may have seen some videos where we change from log form to exponential form just by doing this little circular thing where we say, 5 raised to this power gives me 1/5. So if you know your exponent rules, that's clearly a -1. That you'd have to take 5 and raise to the -1 to get 1/5. So that one's in my list, so I skip to that one. That one is -1. And moving on to the next one. So this says that 5 raised to some power is supposed to give me 1/25. We know that 5 squared is 25, but the only way you're going to get the 25 to end up in the denominator is to use a negative exponent. So the fact that 5 squared is 25, but you want the 25 in the denominator means you have to use a negative exponent. So the answer to that one would be -2. 5 squared would give me the 25. The negative exponent would put it in the denominator. That one came out to be nothing more than -2. This one you'd have to again be familiar with exponent rules. In fact, I tend to think of this as partly a log problem, but mainly an exponent rule problem. So this is some number, which I'm trying to find. It's equal to some number, question mark. And if you changed from log form to exponential, it would say 5 raised to some number is supposed to give me the square root of 5. So 5 to what power would be the square root of 5? Well, the square root of 5 is the same thing as taking 5 and raising to the 1/2 power. So I basically already answered that when I showed you the exponent rules. So the question mark over here would have to be 1/2. So 5 to the 1/2 is the square root of 5. And that makes this answer 1/2. Now there is one that I skipped. So now for the last one, now that you get an idea of the exponent rules that we went through, let's look at log base 5 of 0. And by the way, you are never to plug in a negative number or 0 into a log function because it's not defined to give a real number output. But that doesn't really help explain why. So let me start by saying this is question mark here. So the idea is just to explain what the meaning of the problem is that we are to take the base 5 and raise to some power to give 0. So the reason this is difficult to explain is simply that there isn't an answer, but I'll attempt to do so anyway. So to me, there's 3 possibilities of what the question mark could be. You could replace the question mark with a positive number, or you could replace it with 0, or you could replace it with a negative number, and perhaps this will give you some idea. So let's take the first case where we proceed to plug in a bunch of positive possibilities, like 5 to the 0.1, or 5 to the first, or 5 squared. I don't care what number you give me, you are just never going to get 0. So for example, 5 squared is 25, that's too big. 5 to the first is 5, that's still too big. 5 to the 0.1, I don't want to get into the exponent rule there, but it would still be some positive result. It just simply would not give 0. So case 1 just doesn't work out. 5 to a positive number simply is not going to give you 0. Case 2 is where you replace the question mark with 0. Is 5 to the 0 power 0? It turns out in mathematics that we define things to the 0 power to be 1. So since 5 to the 0 is 1, we can't say that 5 to the 0 is 0. So case 2 is out, and case 1 was out. So we're on to the third case. So for the third case, this is where we replace the question mark with a negative number. If you replace it with a negative number, say -1, remember that this really still is 5 to the first, which is 5. The negative exponent just puts it into the denominator. So this doesn't work out any more than 5 to the first did. My argument for 5 to the first was that it was just 5. My argument for 5 to the -1 is that it's 1/5. So putting things in the denominator did not turn numbers into 0. And you could argue the same thing with an exponent of 2. 5 squared was 25. Making the exponent negative doesn't help if your goal was to make this 0. That would just be 1/25. So putting these numbers in the denominator is never going to make a fraction come out to be 0. So I don't know if you buy it, but I can't imagine any number, positive, 0, or negative, in a way that would define this to be a true statement. 5 to no number is 0. Therefore, this simply does not exist, and that's what they're asking for in this question. Log base 5 of 0 does not exist.